All right, so last time we were doing the probability of independent events. We were looking at two different events that did not affect each other and the probability of one happening and the other one happening. This time we're going to look at two events that the first one actually affects the second one in here. So we're going to start off using a game here. To win the game, she must select two 50-point cards in a row. After Nancy selects one card, it is not replaced, and that's how in that way it does not. It actually is going to affect what happens in the second part. And then she's going to select at random from 5 10-point cards, 4 20-point cards, and 2 50-point cards. So there are 11 cards in total, and Nancy's going to select her first card. So what's the probability that first one is a 50-point card? Well, if we look at, we have a total of 11 different cards here, and there are 2 of them that are 50, so the probability that that first one is a 50-point card is going to be 2 out of 11. 2, the total number of times she can select a 50-point card, and 11, the total number of cards. Right. So now she's taken one of these 50-point cards out. This one's gone. Okay, so what's the probability on the next pick that she's going to choose a 50? Well, there's only 150 left. And in fact, there's not even 11 total cards left anymore. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one's gone. She's already selected it. So she's got a 1 out of 10 chance of the next one. So how do we find the total probability? As usual, we multiply those two probabilities together. 2 11ths, the fundamental counting principle, we multiply these. 2 11ths times 1/10. The 2 and the 10 can reduce to 1 and 5. And then we multiply across. 1 times 1 is 1. 11 times 5 gives us 55. So it's the probability of selecting 2 50-point cards in a row is 1 out of 55. So not a very likely chance that she's going to win this game when she has to select 2 50-point cards. Okay. So the next page is actually referring to the same game, the same situation, the same cards here. So we'll do a couple of these together, and then I'll let you do some on your own. So I want to look at what's the probability that she chooses 2 10-point cards in a row. We're doing this first one here. There's not a lot of room to write on this piece of paper. You might want to pull out another piece of paper. You can kind of cram it in the corner like I'm going to do here. But that's just one of the things that we're going to have to do. So what's the probability that she chooses 2 10-point cards in a row? Okay, once again, we start off with 11 total cards here. And what's the probability that the first one is going to be a 10? Well, there's 1, 2, 3, 4, 5 different 10s out of a total of 11 cards. So for number 1 here, the first probability that first card is 5 10s out of a total of 11 cards. Now, we're going to be multiplying that by the probability that the second card is a 10. Well, now we no longer have 5 10s. We've chosen one, so we have 4. And we no longer have 11 total cards either. We have 10 total cards. So we're going to try to reduce where we can. 5 and 10 go in. 5 goes into 5 once, goes into 10 twice. We can also reduce that 4 and the 2. 2 goes into 2 once and into 4 twice. So we're going to end up with the answer to number 1 is going to be 2 over 11. So let's go ahead and do number 3 together here. I'm going to skip over number 2. I'm going to have you go back and do that one on your own. Let's take a look at number 3 here. What's the probability that I get a 10-point card and then a 20-point card? Well, the 10-point card is the same as the last time. I've got 5 10-point cards out of 11. And now what's the probability the next one is a 20-point card? Well, I haven't chosen a 20-point card yet. I still have 1, 2, 3, 4 of them. So I have 4 of them. That number doesn't go down from the number of 20-point cards I have. But I do know I have chosen one of those 10, so there's not 11 cards anymore. There are still 10. So actually, this one is going to end up with the same answer here as 2 11ths as we had. Those are the same 2 fractions being multiplied together to get us 2 11ths. All right, so I want you to go ahead, finish all of 1 through 6 there in exploratory exercises, and then check your answers with mine. All right, I'm going to show you the answers to these. These are the even ones here. And then let me take you over to show you number 5 that I hadn't showed you here before. If you're getting a different answer or you don't understand where these numbers come from, make sure that you ask for help. This is really a really important time to ask for help to be able to understand what you're doing. So now we're going to take a look at the next situation. These are going to be actually asking the same questions, but the rules are changed here. This time, that first card that is drawn is replaced. This is actually going to take us back to the independent events, the probability of independent events, because they're not going to affect each other. So each time the card is replaced, so that each time that they choose, there's going to be 11 cards. All right, so let's go ahead and do the first one here together. So what's the probability that we get two 10-point cards in a row? What's the probability? The first one is a 10-point card. Would be there are 5 10-point cards out of a total of 11. And the second time, well, we're replacing it, the odds are going to be the same thing. What's the probability? The next one is a 10-point card. There's still 5 10-point cards out of 11. That card has been replaced, so the odds do not change. That's why these are independent events. We multiply those together, and we're going to get 25 over 121. Okay, now that you understand that those, go ahead and finish off all the way up through number 12, and then check your answers with mine. So here are the answers to the odd ones on this side, and then we can slide this over and look at the answers to the even ones on this side. Once again, if you're having trouble, please make sure that you're asking questions before we go on to the next part. Okay, now you're going to want to do the written exercises here. Just do parts 1 through 10. And then please check the solutions with me. Make sure you get this practice in. This is really important that if you can do these 2 sections here, you're going to be pretty well prepared for being able to do this on the test. But the practice is really important to get this down. Don't just skip ahead and just copy my answers in here. It's really important that you get this practice in. So here are the solutions to the odds 1 through 9. Keep in mind that when you're reducing these fractions, we can reduce fractions that are both right on top of each other. For example, when we have the 3 over the 9, that can reduce right down to 1 over 3. We can also reduce them when they're at a corner from each other, diagonal from each other. So like the 2 over 8 can go down to a 1 and a 4. So anything on the top can be reduced with anything on the bottom. I'm going to move it over to show you the even ones now. If we take a look over here, I did not do 8 and 10 yet because I want to explain that. So take a look at the answers for 2, 4, and 6. Now, number 8 asks a question, what's the probability that both marbles drawn have the same color? Well, having the same color must either be the situation where we have 2 red marbles being chosen in a row, or it must be the situation where I have 2 blue marbles chosen in a row, or the other option is it's going to be where it's 2 white marbles in a row. Okay, so, and in fact, we're basically finding the probability of finding this one, the 2 red marbles, or 2 blue marbles, or 2 white marbles. When I use that word or, I'm actually going to be adding up all of those probabilities. So, for example, when I go ahead and write this down here. Probability of 2 blue was 1/6. The probability of 2 red marbles in a row was 1/12. I'm going to add up all of those probabilities. And the probability of 2 white marbles in a row was 1/36. Okay, and I'm going to have to get a common denominator of 36. So this is going to become 6 out of 36 plus 3 out of 36 plus 1 out of 36. 6 plus 3 is 9, plus 1 is 10. So that gives me 10 out of 36, which can be reduced down to 5 over 18. So the probability of both marbles drawn having the same color is a 5 over 18. That actually means, and then everything else is going, that actually helps us answer the next question, because every other possibility is where both marbles drawn having different colors. These are all the ones where they have the same color, and it adds up to 5/18. So if 5 out of 18 are them all having the same color, how many out of 18? The remainder of this probability, what adds up to 18. 5 plus what gives me 18? That will add up to that. Well, 5 plus 13. So this must actually be 13 out of 18 must be the probability that they're having a different color. So I'm using some of the work that I've already done to help me figure out the answers to number 8 here. and I add up all those and I get 5/18, and then I know that the probability of this one plus the probability of this one must be 100%. It must add up to 1. So we're basically saying 18/18 minus 5/18 gives me 13/18. This is the probability of them not. There's only two possibilities. They have the same color or they have different colors. So that's going to add, the total probability of all those things happen is 100%. They're either going to have that, but each one, this one's 5/18 and this one's 13/18. Okay, let's go ahead and take a look at the next question here. So I just want to help people with this problem because not everyone's that familiar with a standard deck of cards. There's 52 cards. Of each type of card, like a 3 here, or a queen, or a king, each of those, there's 4 of each. So there's in this deck of 52 cards, there's 4 queens, there's 4 3s, there's 4 kings, there's 4 aces. They also come in suits. And so there are diamonds, there are clubs, there are hearts, and what do they call it here? Do they have spades? Yeah, I guess they don't say that in this one here, but there are 4. So basically, there are 4 different suits, and if you do 52 divided by 4, you get 13. So there's actually 13 cards of every suit that's in here. So that's basically all the information that you need to be able to do these problems. Go ahead and give this a shot. Again, this is once a card is selected, it is not replaced. Go ahead, just try doing the odd ones first. Let's check those, and then we'll go on to do the even ones after that. Go ahead and just do the odd ones for now, and then check. I changed my mind. I wanted to do one of these with you together. So let's do the first one, number 11. In this particular case here, if we have 11, we're going to have, what's the probability of, out of those 52 cards, I choose a queen? Well, there's 4 queens out of 52 cards. Now I've chosen that queen, and the queen is no longer in the cards. What's the probability the next one is a 3? Well, there's 4 3s, but now there's only 51 cards. And one of the nice things about reducing these fractions is that 4 actually goes into 52, so we can reduce that. It actually goes in 13 times. 4 goes into 52, 13. So it's actually helpful to know for most of this that 13 times 4 is 52. That really helps us reduce it. Unfortunately, 4 does not go into 51, so we're going to have to multiply 13 times 52 to get that answer. And we'll get 4 out of 663 is the probability that you get a queen and then a 3. All right, go ahead and finish off those odd ones up through number 19, and then check back with me. Okay, here are the answers for the rest of the odds. Take a look at these, and then go ahead and work on the evens after that. If you have any questions, make sure that you ask. All right, go ahead and take a look at these answers for the evens here. If you have any mistakes, correct them, or if I have any mistakes, let me know, and then I can put it onto this Ed puzzle for next year. But please take a look closely and see if you can find any mistakes on yours or mine.